Hi everyone. In continuation to the earlier video on loss of pressures due to friction, we will solve a problem. Now I'm going to solve the example problem from Prestress Concrete by N. Krishna Raju. Here you can see in page number 137, you can see this example. A concrete beam of 10 meters span, 100 wide and 300 deep is pre-stressed by 3 cables. The area of each cable is 200 square and initial stress in the cable is 1200 Newton per square. Cable 1 is parabolic with an eccentricity of 50 above the centroid at supports and 50 below at the center of the span. Cable 2 is also parabolic with 0 eccentricity at supports and 50 below the centroid at the center of span. Cable 3 is straight with uniform eccentricity of 50 below the centroid. If the cables are tensioned from one end only, estimate the percentage loss of stress in each cable due to friction. This is a question. We will solve this one. Here, the pre-stressed beam of span 10 meters. This is a 10 meter span beam, right? Having a width of 100 and depth 300 This is the central axis of this beam and it is having 3 cables of each area. Each cross-sectional area of the steel will be 200 square and initial pre-stress is 1200 Newton per square, right? Cable 1 is maintaining an eccentricity of 50 at supports, 50 at supports and 50 below the central axis at center, means it is also 50. This is cable 1. Next, cable 2 is having 0 eccentricity at cable. There is no eccentricity at ends for cable 2, 0 eccentricity and 50 eccentricity at a center, right? There is no eccentricity for cable 2. This is the cable 2. Next, coming to this cable 3. Cable 3 is the main is a straight cable. It is maintaining the same 50 eccentricity throughout the span. This is 50 cable 3. Right? Now we need to determine percentage loss of stress in steel due to friction. This is we need to determine, right? In question it is also given, we can take mu as 0.35 and K we can take as 0.0015 per meter, right? Now how can we solve this problem? To solve this one, we know the equation Px is equal to P naught into e power of minus times mu alpha plus kx, right? For small mu alpha plus kx, we can rewrite this formula as Px is equal to P naught into 1 minus mu alpha plus Kx, right? This formula we know, right? What we need to do, determine to use this one. Mu already given, see, mu already given, mu is 0.35. Alpha we need to determine, K is given 0.0015, and this x will be the distance. X will be the distance we know, right? We know that is the say this is the span is 10 meters, like we can take it as a 10, no issue with it, right? How can we determine the alpha value? Alpha value, see, cable 1, this is the central axis. Cable 1 is having an eccentricity at ends 50 and at center 50, ends is 50. This is cable 1, right? Cable 1 means here we, to determine this alpha value, we can use this equation of parabola. Y is equal to 4e by L square into x into L minus x, right? I can rewrite this equation as 4e by L square Lx minus x square, right? Now slope of this one will be dy by dx is equal to, differentiation with respect to x will give the slope of this line, 4e by L square L minus 2x, right? Now this is the slope. Now I need to determine slope at end, means dy by dx is equal to dy by dx at distance of x is equal to 0, right? At end, if you want to determine the slope, dy by dx can be determined with x equals to 0, right? With x equals to 0. dy by dx is equal to 4e by L square L minus 2x. Now for end x equals to 0 means 4e by L square L minus 2 times of 0, that is equal to 4e by L. This is slope at the end. Slope at the end. As I said, in the case of cable 1, we may have two alphas. This is one alpha. This is another alpha, right? That's why in the case of cable 1, alpha is equal to 2 into 4e by L. 2 into 4. In the case of cable 1, eccentricity will be 100 plus 100. Sorry, 50 plus 50, 100. 100 by total length 10 meters, right? That is equal to 0.08. This is the alpha, 0.08 radians, right? Next, coming to cable 2. Cable 2. Cable 2 is maintaining eccentricity at center only. This is the central axis. See, here cable 2 is maintaining eccentricity at ends only. Eccentricity at center only. There is no eccentricity at ends. Suppose this is central axis. Cable 2 is having no eccentricity, E equals to 0 at ends, but at center there is an eccentricity. Here it is maintaining the eccentricity of 50 mm. Here also alpha is equal to 2 times of 4E by L. 2 into 4 into eccentricity is only 50 by 2 into 4 into eccentricity is only 50 by L, total length 10 into 1000. I am converting it into mm. The value will be 0.04 radians. 0.04 radians. Coming to cable 3. Coming to cable 3. This is the central axis. Coming to cable 3. This is the central axis. Here cable 3 is maintaining the constant eccentricity throughout the length, 50 mm. Constant eccentricity. There is no slope. Slope equals to 0. There is no slope. Right? Now, equation is Px is equal to P0 into 1 minus mu alpha plus Kx. Right? In the case of cable 1, for cable 1, P0 into this term will give the loss. This term will give the loss. Means if you wanna determine the loss of prestress, loss of prestress will be P0 times mu alpha plus Kx. Mu alpha plus Kx. P0 into, what is the mu value? Mu value is given as 0.35. For cable 1, alpha will be 0.08 plus K is given as 0.0015 per meter. The total length is 10 meters. The value will be 0.0043 P0. This is in cable 1. In cable 2, P0 times mu is 0.35, alpha is 0.04 plus K value will be 0.0015 times 0.0015 per meter, total 10 meters span. This value is 0.029 P0. Cable 3, P0 times, there is no alpha, there is no slope, means there is no alpha, means this term will be 0 plus 0.0015 times 10, that is equal to 0.015 P naught. Right? We know the initial value. P naught is 1200 Newton per mm square given in the question, right? Given in the question. P naught is given as, see, P initial precessing force 1200 Newton per mm square is given. So in cable 1, loss of prestress is equal to 0.0043 into 1200, that is equal to 51.6 Newton per mm square. And in cable 2, 0.029 into 1200, that is equal to 34.8 Newton per mm square. For cable 3, 0.015 into 1200, that is equal to 18 Newton per mm square. If you want to determine the percentage of loss, in cable 1 it is 51.6 out of 1200, that is 4.3%. In cable 2 the loss will be 34.8 out of 1200. The loss will be into 100, we need to give. The loss will be 2.9%. In cable 3, the percentage of loss will be 18 by 1200 into 100, that is equal to 1.5%. Okay, these are the percentage of loss due to friction. Okay, thank you.